I remember when I was in high school learning about atomic radius, I predicted that atoms should get bigger as we go across the row. It was obvious to me because we're adding protons and electrons and neutrons, so there's more particles. They should have, they need more room. So atoms should clearly get bigger, and I was absolutely wrong. I couldn't be more wrong with my prediction because it's the opposite. Atoms are getting smaller as we go across the row. Even though we are adding protons and electrons, well, how can they get smaller then? Well, the thing is that I wasn't realizing was energy sublevels and orbitals that electrons go into. Orbitals are already places that are reserved for electrons. And whether electrons are in there or not, that whole electron cloud gets drawn in. So as we go from the left to the right, the nucleus is getting more and more positive. We're adding another proton to the nucleus every time. So you got this growing positive charge, and that draws that whole cloud of electrons in more tightly to it. Because the electrons already have a place in those energy levels that's reserved for them. It's not like another electron comes along and just has to go on top of where the other ones are. No, it's got a place that it fits in. So in that cloud, there's a space for it. So that draws the whole energy levels, the whole cloud of electrons in more tightly. So as we go to the next row, then we have to start a new energy level, so the electrons have to kind of start over again. And once again, we have that shielding effect. That really would get to the next thing where we're going down a family. But yeah, within a row, it's the effective nuclear charge is going up. And then finally, this is the last slide. Yeah, as we don't go down a family, you don't have any choice. When you put a new energy level on, it has to go on the outside of the old energy level, so naturally atoms are going to get bigger. Go down any family on the periodic table, and the atoms have to get bigger as you go because there's electrons being handed out. And the bigger you go, the outer electrons can feel the inner, the nucleus less and less. Again, we have this term, the shielding effect. So this shielding effect, I've mentioned it a couple of times now. It's the whole concept of the more piles of electrons you have, the more energy levels of electrons you have, the less the outer electrons can sense that positive charge from the nucleus. I want to give you an analogy about the shielding effect. And I think this will help you to understand it. I want you to imagine, this is not happening, but you have to imagine, that I'm going to give free tickets for all of us to go to Justin Bieber concert. Okay, so that's pretty good news, right, Melvin? That'll be fun. So all of us are going to get together here. The concert's at 7 o'clock, and we're going to get together here. At 5 o'clock, we'll go together. Okay? So we meet at 5 o'clock, and somebody's missing. Let's see, I'm looking around the room. Who would be missing? Kovacs. Yes. Sleeping. He couldn't wake up. So the concert's at 7. We're waiting around. Okay, where's Nate? Where's Nate? It's now 7 o'clock, and he finally shows up. Okay, so should now we go or not go? Well, we got the tickets. Let's just go. So, you know, we're all grumbling and we get in our cars, up to DTE we go. And we get there, we gotta park way as far out as you can get, practically on the next property, walk a mile to the concert, and here we are. Of course, nobody else overslept, so we're the last ones there, and we're way at the back. So, you know, we watch the concert, we can barely see what's going on down there. Walk away, you know, and people are like, wow, you're so lucky you got to go to Justin Bieber, and what do we say? We didn't have any good spot, we couldn't see anything, it wasn't that good. Right? We were shielded. This is the shielding effect. You saw this picture at the beginning. But yeah, these electrons over here, they can really feel the nucleus, and they get to enjoy the positive nucleus. And then us, you know, we're way out here, and we don't really get the same experience with the nucleus. That's the shielding effect. We were shielded by all the others that were in closer. These people, you know, what are they saying? Ah, Justin Bieber! You know? And here's us, we're like, this is not that good, right? So anyway, that is what the shielding effect is. And so when you hear that, it is a really important thing. It's kind of a buzz term that people that read tests like to read about, your understanding of what that means, those outer electrons. When you have, you know, these layers of electrons in an atom, keep that in mind. Okay, so that's it for today. Tomorrow we got to go over two other periodic properties. We got to talk about electronegativity we didn't get to today. And then ionic radius. What happens to the size of an atom when it becomes an ion? All right. We're done.